Hello, welcome to another cool math video. My name is Ali. Today we are going to look at system of equation problems. Usually when you have two equations and two unknowns, you can solve a system of equations. Three equations, three unknowns, you need three equations. Four unknowns, you need four equations. But what if you don't have enough equations? You have three unknowns, but only two equations. What do you do then? So let's see a past competition problem with this. All right. Here's a problem which gives two equations with A, B, C unknowns. So three unknowns, but only two equations, and they're asking something about relating A, B, C. What do? We cannot, probably we cannot find a unique solution for this because we have too many unknowns, right? More unknowns than the equations. So we are just missing one equation, right? Is it necessarily a bad thing? No, we can come up with our equation. You can say A equals 5, B equals 3, A equals B, C equals 17, whatever you want. Probably something convenient, right? So let's see what might be convenient. Usually, setting one of the unknowns equals 0, or two of the unknowns to be equal, or something that gives some nice cancellations or something would be good. So let's try to have the third equation. So we have A minus 7B plus 8C equals 4. 8A plus 4B minus C equals 7. For the third equation, since they didn't restrict us what it is, we can set, let's say, C equals 0. Then we'll have A minus 7B equals 4 and 8A plus 4B equals 7. 8A plus 4B. Coefficients are both multiples of 4, but 7 is not. So let's change this 0 to 1 so that the right-hand side would be 8, a multiple of 4. As I said, whatever is convenient for you, you can set up as you like. Nobody's going to come and say y is equals to 1. You cannot make that. There are no such rules, so feel free. And then our equations become A minus 7B equals, C is 1 now, so this is negative 4. And 8A plus 4B now is 8, so let's divide everything by 4 to get 2A plus B equals 2. Then this is two unknowns with two equations, so we should be able to solve this. Let's get rid of, I guess there are several methods. We can substitute A equals 7B minus 4, plug that in the second equation and solve for B. Or we can play with these equations to get rid of the B coefficient. That's what I like more. Let's multiply the second equation by 7 and add these equations so that we can get an equation with just A. So 14 plus 1, 15A. The B coefficients cancel each other. We get minus 4 plus 14. That's a 10. So from here, we find that A equals 2/3. And then, using just one of the equations, you can find the other unknown. 4/3, 2 minus 4/3. That's also 2/3. Interesting. So if we had set up A equals B at the beginning instead of C equals 1, we would probably get the same solution, the same triple. So we find that this is one of the solutions. A, B, C triple equals 2/3, 2/3, and 1. This is one of many solutions. So you could come up with another triple solution, which is fine. For the problem to be correct, A squared minus B squared plus C squared should be the same for whatever triple you find. So in this case, A and B are the same. So A squared minus B squared cancel out each other, and you get a 1 at the end. Meaning, since A squared minus B squared plus C squared is the same for all the solutions, there should be a reason for that. There should be a nice tricky solution for this. But that's hard to see. I'm gonna just quickly sketch that. Here, because of the nice symmetry in the coefficients, you can see that A plus 8C equals 4 plus 7B and 8a minus c equals 7 minus 4b. You see the symmetry nice between the coefficients 1, 8, 8 minus 1, and 4, 7, 7 minus 4. Some sort of symmetry going on behind the scenes. So if we square these and add them up, and sum these, you see that the minus and plus terms cancel each other because they have the same coefficients at the end. So we are left with 65 a squared plus c squared equals 49 plus 16. That's wow, also 65. Interesting. Plus 65b squared. Aha, turns out this is the reason. 4 squared plus 7 squared equals 1 squared plus 8 squared. They are both 65. And because of that, things cancel each other and you get a squared plus c squared minus b squared. If you divide both sides by 65, you get this is equal to 1. But this is pretty tricky. It's hard to see. It's a cool solution. But you have much more flexibility than this. You can set up your third equation as you like, since you have 1 degree of freedom. All right, I hope you enjoyed this movie. For more videos like this, please subscribe. Thank you.